So in this video, we're going to see a data structure question from the year GATE 2014 and it's based on the topic of maximum heap. So let's see what the question is. Now a priority queue is implemented as a max heap. Initially, it has 5 elements. The level order traversal of the heap is 10, 8, 5, 3, 2. So this is the level order traversal of the input max heap. Let's make a note of it. Okay, let me draw here the max heap. So this is my 10. Okay, and then next we have 8 and 5. So 8 and 5, and next we have 3 and 2. So this is going to be my 3 and this is going to be my 2. Okay, now 2 new elements 1 and 7 are inserted into the heap in that order. So first we have inserted 1 and then we have inserted 7. Now the level order traversal of the heap after the insertion of the elements is, so after inserting these 2 elements 1 and 7, what is the new level order traversal? Simple question, that's what we have to find out. Now before we go ahead, let's quickly see what is a definition of a max heap. So typically a max heap is something which has a parent here and it has 2 children. It has only 2 children, and the value of the parent node is always greater than or equal to the value of his children node. That is a typical property of a max heap. It is always maintained. And there's one more property of a max heap, and that is there is always a level order insertion of the new nodes. So whenever the new nodes are added, they're always added in the level order. Okay, so when this new node will be added, now 1 and 7, right? So first we're going to insert 1. So 1 will be inserted in a level way. So this level is full, second level is full, so it will be inserted at the third level here. So this is where 1 will go. Now after inserting 1, let us confirm that this first property is maintained throughout the heap. Okay, so as you can see, 1 is added to this node, so 5 has become a parent, and the value of parent is greater than the value of his child. So this property is satisfied, no need to do anything. This is a safe insertion. Now next, we are going to insert the node 7. So again, the insertion has to be level wise. Since this level is still empty, it's not full, we are going to insert 7 here. So 7 is going to insert it here. Now again, once the insertion is done, let us check if this first property holds or not. So very clearly 5 is the parent and 7 is the child, but 5 is not greater than 7. So this property is not holding. So whenever this property is not satisfied, we do an operation called as bubble up. So in bubble up, what happens is, let's zoom in here. Okay, so in bubble up, what happens is 5 is the parent which has less value, 7 is the child which has greater value. We are just going to swap these 2 nodes. So 7 is going to come here and 5 is going to come here. Once this swapping is done, we once again check the property of the max heap. That is the parent node now. Is it greater than the child node? Yes. Here it's already greater and it's also greater here. And we also check the above parent. So 10 has to be greater than 8 and 7 is children. So the max heap property is satisfied in all the nodes here. The parent, every parent here has a greater value than his child. So that property is satisfied, and this is our new max heap after the insertion of 2 nodes 1 and 7. Now let's find the level order traversal of this. So the level order traversal is going to be 10. Okay, 10 at first level, followed by 8 and 7. So 8 and 7 at the second level, followed by 3, 2, 1, 5 at the third level. So this option should be there somewhere. Yes, I can see it in option A. So option A has 10, 8, 7, 3, 2, 1, 5. So option A becomes our right answer.